the restriction. So that's the first question, in which it's going to be 3.1. Then 3.2, that is when we are supposed to express these three in terms of m. So that one is just going to require us to use the reduction formula. I hope you guys are already aware of reduction formula. Then moving forward, 3.3, that is when we're supposed to be able to change now. Let me reduce the volume there. It's music that is playing in the background. So now, as you can simply see now here, I'm supposed to obviously use the cast to simplify 3.3 fully. Then 3.4, I'm supposed to prove that identity there. Even on 3.5, I'm supposed to prove that identity again. Then on 3.6, we'll be doing a nice problem, which is simply based on general solution. We are given 2 sine squared theta equal to 1 plus sine theta. Then all in all, it's just going to be 34 marks. Imagine, guys, so simple questions, then they give you 34 marks. This is just a bonus of marks. They're just giving you marks for free. Look at these kinds of problems. All of them are just simple and straightforward. But now I'm just gonna simplify them for you so you see how simple math can be at some point. So now, let's work. Let me prepare my calculator so that it's here next to me, because I'm just gonna be using it a lot. So let's check the calculator. Yes, my calculator is on my phone, guys. You can also download yours. Here is mine on my phone. It's a calculator. So you can also download yours there. It's a scientific calculator on App Store. Now let's check. You're gonna try to see my handwriting, because honestly, I'm not used to this. I'm used to the board. Not these. But yeah, I just wanna adapt to these because they make lessons very fast. Then yeah, let's just work. I think I'm just gonna have to switch off these because they're just gonna disturb me. Yeah, now let me continue. 3.1, guys, there we are given this, just a simple, we're given -3, we're given -3 sine beta minus 2, which is equals to 0, and we're given that beta is the element of 0 degrees to 270 degrees. That's what we are given. We're supposed to use a sketch in the correct quadrant to determine the value of 1 plus tan squared beta without using a calculator. So now I want you to understand the fact that when it comes to this problem, it's a must for you to draw that sketch, understand, so that you can do things in a correct way. Let's look now. Let's see. Let's just draw that sketch on the side. Remember, it's supposed to be cast. It's C, A here, S here, and T here. Sorry about that, but okay, let me just fix it. Let me just fix that. It's just going to be cast, né? So let's draw that graph there. It's cast, yes, cast. We usually cram this cast. Sometimes I use cast. I know that C is supposed to be on my 4th quadrant, then A, S, T. Someone starts from the 1st quadrant and they simply say all stations to Cape Town. Understand? All stations to Cape Town. So we also use that with my students. At the same time, it's cast. Now let's check. Here we have 0 degrees, here we have 90 degrees, here we have 180 degrees, here we have 270 degrees, here we have 360 degrees. That's what we have. Now let's see. This triangle, the triangle that we are working with, is supposed to fall under 0 degrees to 270, meaning that we start from 0 here, we start from 0, we go to 180 and 90, we move to 180 to 270. So, meaning that this triangle is supposed to be in these three. But let's use this again to get more instruction, because this one tells us these are the quadrants we're supposed to play around. Let me remove this. These are the quadrants we're supposed to play around, right? Now this one here, negative 3 sine beta minus 2. Let's just try to solve this. Negative 3 sine beta is equals to 2. Then we divide both sides by negative 3, negative 3. Then this one cancels this one. Then now we know that sine beta is supposed to be equals to negative 2 over 3. But now, let's think about something. What does SOHCAHTOA mean? SOHCAHTOA mean? SOHCAHTOA tells us that a sine is opposite over hypotenuse, meaning that this sine beta here is opposite over h. And if we know that that sine is opposite over hypotenuse, we must understand that this 2 here is supposed to be for opposite, this 3 is supposed to be for hypotenuse side. But now we know for a fact that every time we use Pythagoras theorem to calculate the hypotenuse side, we will always get positive for the hypotenuse side, meaning that opposite is supposed to be negative. And remember, opposite, when you look at the fact that we represent opposite with y, we represent adjacent with x, then we represent h with r when we are dealing with the Cartesian plane. Now, if we are going to say y is the opposite, then meaning that y lies on the vertical axis there. And if it's that vertical axis, we know from the origin in a Cartesian plane going down, that is when we find the negative values. And from the origin going up, that is when we find the positive values. Now, this simply means to us, our sine beta, our triangle is supposed to be in this one here. So meaning that this is going to be our triangle here. We're going to draw our hypotenuse side from the origin, then we draw this one here. And now we know that r is supposed to be 3, then y is supposed to be negative 2. We don't know what is going to be the side on the adjacent side. Let's try to calculate the adjacent side. I'm going to write it here, then I remove it. So we will use x squared plus y squared is equals to r squared. Now, x squared is the one that we don't know, plus. Do we know y squared? Yes, we know y squared. Our y squared is supposed to be negative 2 squared, which is equals to a 3. Let me fix that. Which is supposed to be equals to 3. I don't know, it's too hot. Okay. Now, let's continue. So when you look at this part now, we have x squared again now. X squared, this is supposed to be plus 4, which is equals to 3. And once we know that, okay, fine, that's the case, then our x squared is supposed to be equals to, 3 squared there. It's supposed to be 3 squared. I'm making a mistake here. So this now is going to be 9. This one is going to be 9. So we're going to have 9 minus 4 here, which is now x squared is going to be 5 here. Then we square both sides. Remember, guys, you must not forget how we really remove that square there. Then our x is going to be equals to square root of 5. Then that is when we know that, okay, fine, here it's going to be square root of 5, which is negative. Why? Simply because, therefore, this one is plus or minus, which is going to be x is equals to negative root 5, because of the fact that from the origin to the left we get the negative values. Now let me remove these. Okay, fine. Now this is what we have. This is the triangle we're supposed to use. Remember now, on this here, on here, we're supposed to find 1 plus tan squared beta. Here it's plus. So, and this is supposed to be 1 plus, we can open bracket and put tan beta squared. Then it's 1 plus. What is tan? Tan is supposed to be opposite over adjacent, which is opposite, it's negative 2 over our adjacent, which is negative root 5 square. Let me prepare to calculate here. Okay, it's 1 plus, these already cancel each other. Then we have this. We don't even have to use the calculator. This is very simple. 1 plus 4 over 5, which is going to be equals to, is it 9 over 5? No? I think it's 9, because it's going to be 5 divided by 5. It's 9 over 5. 9 over 5. We don't even have to calculate that. It's very, very basic. So you can simply see now that we got now our 5 marks here. So we got these 5 marks. Then let's move. I'm trying to find an easy way of removing everything, but going forward, I know I'm gonna find something, because I wanna learn how to. Okay, let me go back to this. I wanna simply learn. Okay, we're still going to use that cast today. Okay, let's continue. Okay, now going back to that, you can simply see that on 3.2, we are now given that cos 75 degrees is supposed to be equals to m. And if cos 75 degrees is supposed to be m, then we need to express cos squared 105 degrees in terms of m. And now if we can think about it, 105, we find 105 from 90 here to 180 degrees. Understand? And we know the reduction formula that we find between 90 and 180, it's supposed to be 90 degrees plus theta, or 180 degrees minus theta. And if that's the case, then cos squared supposed to be 180 degrees minus 75 degrees in order for us to find 105. So you can simply write this in terms of cos 180 degrees minus 75 degrees all squared. Then that's when you can just do that. Then from there you can simply see that since we have 180 degrees minus 75 degrees there, then that is when we know for a fact that okay, cos on this one, it's supposed to be negative cos 75 degrees. Why? Because on our second quadrant, only sign is positive. Then this one here, it's going to be negative times negative, it's positive. So it's positive cos 75 degrees. Cos squared 75, ne? No, let me write it in terms of, let me just do this. Remember, we know that cos 75 is m, right? So let's just write it like this. Then we know for a fact that we're just going to get, we're now going to get a square here. And if this is a square, then we get m squared as our final answer. Then we are done from there. Then I want you to always remember the fact that how to deal with these squares that are outside, how to separate this square, remove this square and put it outside. Understand? You must know how to do that and make sure there are no mistakes, because most of the time what makes a lot of students to lose marks, it's how they use small things. Understand? If you can understand how to do that, then you'll start being good in a lot of things you're doing. I don't know why is it doing this now. Unable to sync changes. Please check your network connection. Can I pause a little bit, guys? Can I pause? I'm gonna come back.
Okay, sorry about that, guys. Oh, I had to fix my sound. I didn't realize that it was disconnected. At the same time, my router here, it just switched off. I don't know what happened. But yeah, now I'm back. Sorry about that. Now let me continue. So we move to the second one. Let me just remove what is here so that I can finish fast. And also remove this. I'm not going to need it. Okay. Okay, now I want us to focus on sine 15 degrees. How do we express sine 15 degrees now in terms of m? I want you to think of something. Already we saw that, okay, before name, sine 15 degrees is supposed to be, so which is opposite over hypotenuse side. Understand? And if we know that it's supposed to be opposite over the hypotenuse side, then sine 15 degrees is simply, look at that one. That one is m over 1. And m over 1 simply tells us that it's cos, which is a over, so it's a over h. So meaning that our h, we know for a fact that it's 1, right? Then m is our HSN. So meaning that we got a triangle like this, in which we know that m is the HSN. So we can simply say there is an angle here. This one is 75, right? 75 plus 15, it's supposed to be 90, right? So let's just say, okay, no, not that. Let me do this. Let me do it this way. So I need to represent our sine 15. Let me just do this. Our sine 15, we can simply use 90 degrees minus 75 degrees to get our 15 degrees. So this is going to lead to cos 75 degrees. Then we know for a fact that this is m, right? So this is a simple way. But now remember, if we have 15 and tan here is 15, so we can simply say sine 15, we just realized that it's supposed to be m, right? In which this is over 1. And sine is supposed to be opposite over hypotenuse side. So we know that hypotenuse side is 1, opposite is m. So if we can say x squared plus y squared is equals to r squared, we know for a fact that x squared, we don't know what is x squared, plus y squared, we said it's that opposite, which is m, right? So we're going to say m squared, which is equals to our r squared, it's just 1. So x squared is going to be 1 minus m squared, in which now x is going to be square root of 1 minus m squared. Then if we know that is the case, then what is tan 15 degrees? Because tan 15 degrees is supposed to be opposite over adjacent. Then opposite, we said it's m, which is m over, this is adjacent, which is square root of 1 minus m squared. That's it, guys. So we end up getting what? Our 3 marks there, our 3 marks there, and our 2 marks. So we know for a fact that, okay, fine, we got that. Then let's remove this and move to the next problem. I need to learn a way of removing these things. Same time, I don't know why, because the mouse is giving me problems too. But yeah, let's move to the 3.3 problem. We have now given sine 90 degrees minus x times cos 180 plus x, then plus also given tan x times cos x times sine into x, no, x minus 180 degrees. This is what we're given. We're supposed to simplify this. And we know for a fact that on sine 90 minus x, this always changes to cos x. Why? Simply because the special of 90 and 270, right? So cos 180 plus x, we know that 180 plus x is found on the third quadrant, and on the third quadrant cos is negative, plus you can change sign to sine x over cos x times cos x, so that we can cancel this cos x times. This sign now is going to change to 180 degrees plus x. Then, now we know that we can cancel these two. Then these two, they will give us negative cos squared x plus sine 180 plus x. On 180 plus x, it's on the third quadrant, and sine is supposed to be negative, right? So sine x times negative sine x. So meaning that we have negative cos squared x minus sine squared x. Then we can take out the common factor of negative 1. Then we inside we're left with cos squared x plus sine squared x. And this is an identity to say negative 1 into its 1 here. Then our answer is supposed to be negative 1. Then we are done with that question. So we got our 6 marks. Think about it, guys. Like this, these are free marks. These are just free marks. This question paper was very, very simple. This is another marks, which is 6. Let's remove this and solve a different one now. Yeah, if you have any question, you will leave it on the comment section. Then we will work on that question. Okay, I'll make another video responding to that. That's how I make things to be a little bit quick. At the same time, you can drop your number. I'll put you in my group where I discuss, in my WhatsApp group where I discuss all these problems in a properly manner. Then here, tan theta, we need to prove this side is equals to 1. So in order for us to prove that, we know for a fact that we can simply say left hand side is equals to tan theta, or let me just change tan theta already from the get-go. It's going to be sine theta over cos theta. That's an identity. Then inside we have 1 over sine. No, let me just simplify. Why am I still doing that? Just find the common denominator inside. Common denominator can be our sine squared theta, right? Sine squared theta. Then this sine squared theta divided by sine squared theta is 1 minus sine squared theta divided by 1, it's sine squared theta. Then now we know that, okay, fine, we have sine theta over cos theta multiplied by 1 minus sine squared theta is cos squared theta over sine squared theta. Now I want you to realize that this is a square root and there are two squares here, meaning that we can cancel that square and the square root. Then we are left with just cos theta over sine theta. Then this one cancels this one cancels this. Then we are left with 1. Then we are done proving the left hand side is supposed to be equal to the right hand side. Simple and straightforward. I don't know if you do understand that. Let me deal with that again, and let's so that we can be able to move to second problem. The second problem looks complicated, but nothing is complicated about these problems, just that they need you to practice. And a lot of people don't want to practice. And if you can practice, you will see that in maths, a lot of tests you can score 100%, just that sometimes one thing that can block you is this problem of, it's this thing of, one thing that always prevent a lot of students from scoring 100% is this issue of making mistakes. Because you saw, I've been making some mistakes at some point, but yes, you'll end up not making a lot of mistakes. So we need to prove that this is equals to 4 tan theta over cos theta. And now you can see these are two fractions. We're subtracting two fractions. We need to use the common denominator. And the common denominator can be 1 minus sine theta and 1 plus sine theta. Then this divided by that can be 1 plus sine theta and 1 plus sine theta. You know how to subtract two fractions. If you don't know, you should ask the teacher too. The teachers need to explain all these. They must explain all of them, how to subtract fractions, how to add fractions, how to divide fractions, how to multiply fractions. That concept, it's a concept that is very, very important. If you are not aware of that concept, you're going to come across a lot of issues while you're trying to simplify. And especially when simplifying, it's going to give you a problem. 1 times 1, we get 1 plus sine theta. Let me just say 2 sine theta plus sine squared theta minus 1 times 1 is 1 minus 2 sine theta plus sine squared theta. Let me also simplify this. 1 times 1, we get 1. 1 times sine theta is plus sine theta minus sine theta minus sine squared theta. Then we will get 1 plus 2 sine theta plus sine squared theta minus 1 plus 2 sine theta minus sine squared theta. No. It's very difficult to draw a line here. I know. So this and this, they cancel already. We're left with 1 minus sine squared theta, which is cos squared theta. This one, and is there anywhere I made a mistake? No. This and this cancels, and this cancels. Oh, I'm not seeing that properly. 2 plus 2 is 4 sine theta, which is over cos theta. This is equals to 4 tan theta over cos theta. Therefore, left hand side is equals to our right hand side. Then we are done. We're done with that problem. Let me try to remove all that. Let me try to remove all those very, very fast. Done now. What else now? General solution. Let's find this general solution. 2 sine squared theta is equals to 1 plus sine theta. This might be long. Let me sit and relax now. This might be a bit long. 6 marks. Okay. Let's try to find this general solution. Firstly, we're supposed to transpose everything to one side. Why? Simply because you can see that this is in a form of, look, that's in a form of 2x squared, because there's a square there, equals to 1 plus x. So if you want to simplify this, you're supposed to say 2x squared minus x minus 1 equals to 0. And you will factorize this, right? In terms of 2x and x, then 1 and 1. Then this one is plus, this one is minus. So meaning that here, that's how I make things simple for myself. In most cases, I use this to make things simple for myself. Ne? Then if we can look at the fact that here we have sine, we have 2 sine theta, as well as sine theta, I think, this side. So we have 2 sine theta that side, as well as sine theta this side. Then we're going to have 1 here and 1 here. Then it's plus and minus. And you know, if here you're supposed to if you were supposed to solve this, you were going to equate each bracket to 0 or equate x minus 1 to 0, right? So we do the same thing here. Treat sine theta as x. So here we have 2 sine theta plus 1 equals to 0 or sine theta minus 1 is equals to 0. Then we're going to transpose this one to the other side. Then we will left with 2 sine theta here is equals to minus 1. Here we have sine theta, which is equals to 1. Then remember, we're now supposed to divide both sides by 2 in order for us to remove those 2. Then we are left with sine theta, which is equals to negative 1 over 2. Then this side, it's theta is going to be equals to sine arc, then it's 1. Remember, sine arc at all times is always 90 degrees. Then here, theta is going to be sine arc 1 over 2. Then obviously, this one is supposed to be 30 degrees. Then we are done with those two. Now look, what's the following step from here? We are now supposed to find the general solution of the two. The reference angles we have, it's 30 degrees and 90 degrees. So let's remove these parts here so that we can be able to find that general solution. Okay, let's look at this. Remember now, this one we got sine theta. It was sine theta is equals to negative 1 over 2. Then here it was sine theta is equals to 1. And looking at this cast, sine theta is negative here and here on this one and here. So it's 3 here and 4 here. It's negative, so it's going to be 3 and 4. Then sine theta is positive here on 1 and 2. So here it's going to be 1 and 2. Then what's the general solution of 3? The general solution of 3 is supposed to be 180 degrees plus reference angle plus k times 360 degrees. K is the element of integers. Then the reference angle, remember we got 30, and 180 plus 30 is supposed to be 210 degrees plus k times 360 degrees, which is k is the element of integers. Then we move to 4. 4 it's supposed to be 360 degrees minus reference angle plus k times 360 degrees. Then k is the element of integers. Then 360 minus 30 is 330 degrees plus k times 360 degrees. K is the element of integers. Then moving to 1 here, on number 1, we know for a fact that it's supposed to be just 90 degrees plus k times 360 into k is the element of integers. Then number 2, we have 180 degrees minus reference angle plus k times 360 degrees, which is going to be 90 degrees plus k times 360 into k is the element of integers. Therefore, we can simply see now that our answer is this one, this one, but they're the same there. This one again and this one. So we have 4 general solution. Then in total, we get how many marks? We get these 6 marks. So meaning that when it comes to this test, it was out of 75. If this test was being written by me, I was simply going to get how many marks? 75 over 75. If maybe I would have left those mistakes, then I would have um, lost some marks. So that's the test, guys. It's just a grade 11 test, control test. I forgot which year was that one. I just took screenshots, then I made this video based on that test. So in order for you to prepare for the control test for term 1 in grade 11, then you can simply follow this one and just practice based on this, because we're dealing with just inequalities, sets, exponents, trigonometry, the identities, the reduction formulae, the general solution. It was our last part for term 1. I don't know to other schools, but honestly, if you can also follow this, then surely you can pass your test in with good marks. So yeah, thank you so much, guys. I'm done with it.